Hey everyone, Vessel here, and I wanted to use this video today to talk about the worksheet from last week, the summarizing and comparing distributions. This is it's going to be a video solution set today, so hopefully you find this helpful. We'll go through it and talk about some of the results here and some of the things that I normally see for as common mistakes too. So let's dive in here. This one just sort of starts out: show all work, indicate clearly the methods you use, because you'll be graded on the correctness of your methods as well as your ability to communicate those results. So this were a quiz. this quiz or a test question. I'm going to attack it in that way. So I'll try to be really specific on how to get this correct on a test or a quiz here. So at a school field day, 50 students and 50 faculty members each completed an obstacle course. Descriptive statistics for the completion times in minutes for the two groups are shown below. So we get this summary table here, and basically the first task is to use the same scale to draw box plots for completion times for students and for faculty members. So one thing you got to be careful of, it says on the same scale, and this is usually a good thing to do when you're wanting to compare anyway. You want to put them on the same scale. So just in order to put them on the same scale, we just got to make sure we cover from minimum to maximum type of thing. So you notice looking at minimums, it looks like 3.75 and 4.5, 16.5 and 25. So as long as this line, this is going to be in minutes, that's a kind of an important thing to add here. We need to know what we're actually measuring. As long as it goes from 3.75 to 25, it'll be all set. So I'm going to choose, let's just start at 0. Let's go by 5s or something. 5, 10, 15. That should do. So again, it's by hand. It's not perfect. If I wanted to be super careful, I'd get a ruler. But this will suffice. It's pretty accurate, fairly well scaled out here. And now I just need to figure out how to make the box plot here. So I'll keep students in this darker blue color here. So 3.75. So let's do students about here. And this is an important thing to add. As long as we're going to have two different box plots, we need to label which one's which. So students here, and then we're going to go to Q1, which is 6.75. It's approximately here. This is where the box is going to begin. So here's our first whisker. And before I dive in too much further here, I bet a lot of students would have done this the same way too. It's also possible, we could calculate outliers first. That might not be a bad idea, to be honest, but we don't have to do that here. It just said to draw them on the same scale. So we can do that with the outliers in it or without the outliers. I will say we are going to calculate the outliers in just a minute anyway. So maybe I'll show you what it would look like if you happen to do it the other way. My guess is most students would have just dove right into the box plot, because why wouldn't you? That's what it said to do. So the median next is 9.25. Q3, about 13.75. There's the box. And then the the maximum, 16.5. That's me about here. And I can actually tell from the display that there are not going to be outliers with the student data set. The thing that made me think of it is when we look at this really big maximum for the faculty, it looks like there could be a potential outlier here. So we'll use green. So for the faculty, and these are options. Sometimes students like to do this. It is an option. If you wish, you can put the numbers on here. You don't have to, but if it helps, you can. What we want to do though is stack them. So this one is our faculty. This is the same scale part. So if it's on the same scale, I'm drawing one scale, 2 box plots. Minimum is 4.5, so a little bit higher. Median is 11. Q1 is 8.75. Upper quartile, 15.75. And then this maximum is way out here, 25. Alright. So, got our box plots. This is full credit. Everything's on here. We got the box plots. They're stacked. Everything here looks great. We're ready to move on to actually comparing the two distributions. So now that was the big goal this week, is comparing. Like, what are the things we need to do to compare? So hopefully you checked out some of those other resources. But what we're going to do, and we're going to try to keep it fairly concise, but we have a couple of things we have to do here. We are going to talk about shape. We're going to talk about outliers. We're going to talk about center and spread. Sometimes acronyms can be tools that people use to make sure that they don't mess anything up here. And one of the acronyms that you can use for comparing is called SHOCKS. So SHOCKS comes from shape, outliers, center, and spread. And if that helps you remember, fine. If you don't need that, that's okay too. But basically, anytime we do a comparison, or if it's even just a describing of a distribution, if it's only one distribution, we call it describing. If it's two, we compare. So we're going to write about these four things. And what we all need to do, and when we do these, we can keep this fairly short and concise. We don't want to be writing paragraph upon paragraph. It's usually a sentence, maybe two, for each of these four things. And it's also got to have context, and it's got to have a comparison sentence. So let's get in it here. So shape, for example, let's do students and faculty. So I will caution, and I've tried to caution before with these, it can be challenging sometimes to do shape from a box plot, but we're just going to make our best estimate at it. So what we can use visually is, where does the median fall in the box, and how far is the median from the maximum, and how far is the median from the minimum. So in this case, I think there's two answers that would actually work pretty well here. This one, there is a little bit, I guess the median is on the left side of the box. So what that does is the gap from here to here is shorter than the gap from here to here. That indicates there might be a skew toward the right, a slight one, perhaps. And again, it's hard to know for sure. And then if I look at the gap from the median to the maximum, and the median to the minimum, and it's kind of just like the halfway point. Is there a bigger spread on the upper half of the data, or is there a bigger spread on the lower half of the data? So you can calculate it, but you don't really need to do that. Really, I think if a student said this one looks fairly symmetric, I think that would be perfectly fine here. If a student said it could possibly be slightly skewed to the right, that could also be okay here. So I think both of those answers are fine when doing students. And maybe a way to get around it is a person could say, well, it's definitely more symmetric than the faculty. The faculty has much more of a skew to the right, and you can see this in the box plot because of the long distance between the median and the maximum compared to the median and the minimum. And same thing from the median to the Q1, the median to the Q3. So it's a little bit longer on both sides. I'm much more confident in my assessment of the faculty shape is skewed to the right. Now, while I did say box plots can be kind of tricky, something that's often not tricky to use is using the values. So going up to the table here again for a second, one number, or a comparison of numbers that you can use to see to see shape, is how does the mean and median relate to each other. If you can see, like, the mean is a full minute higher, the mean is larger than the median, that could indicate a slight skew to the right. Same here. This one is a little bit higher, right? So the mean for the students is higher than the median. And outliers, or skew, the mean can really be affected by that. So when you see a mean that's quite a bit different, that's a heavy possible skew. In this case, I wouldn't say either of them are extreme difference based on the scales of these numbers, but the faculty definitely has more of a gap between mean and median, so it's likely more skewed to the right than the students are. And something like that works perfect for our description in this case. So let's get after this description here. Let's see. Sorry about that. All right, so I'm going to use green for faculty. So the distribution of obstacle course times for the faculty is likely skewed right. So you might have noticed, I really wanted to, well, I'm going to highlight something literally here. The distribution of obstacle course times. What I wanted to make sure is that I'm describing here is the context. So sometimes people leave that out. It's very common actually to leave out what this is about. So sometimes people say the faculty are skewed right, and that's not an appropriate shape description. It's not faculty that we're measuring. You have to get it back into what the data is about. It's about obstacle course time. So that needs to be in your write-up somewhere. We don't need to write obstacle course times in all 4 of these things. We can just do it once and we're fine. So we have to meet context though. So it's not about students and faculty. It's about obstacle course time. So that has to be in these write-ups somewhere. And like I said, I'll say it again, you don't have to write it every single time. You have to get the context in this thing at least once. So I like to do it in the first one I do, so it's usually in shape just to get what the context is. And then in the other cases, I'll often get context in here as well, but I'll usually just put it in terms of units, like for the measurements if I can. So anyway, shape is skewed to the right for the faculty, and the student distribution, I'm going to say this, is more symmetric oops, I misspelled it is more symmetric, though maybe a slight skew. It's hard to say for sure. And that's the downside to a box plot. It's really tough to say what the shape is for sure. And if you do say something is skewed, you have to say a direction. You can't just say it is skewed. You have to say if it's skewed to the left or skewed to the right. Basically, the way I like to think about these, whatever you write, the person should be able to visualize in their head what the box plots might look like, or what the histograms might look like, or whatever if they don't have this display, that they could figure it out just based off of your description. So that's the goal when you're making these write-ups here. I'm going to go to center and spread next because they're just going to be a little bit quicker. The center, so this one, you have a couple of choices. And sometimes you get choices, sometimes you don't. So you noticed we were given 2 measures of center. So you can use both here. It's real quick and easy to write about both. So I would just write something like, here I'll do one without using specific numbers and one with. So it's not required that we give the specific number. I'll do one without here. So I'm going to use, I'm just going to stick with this blue color here. The mean and median for the students are lower than the faculty. The mean and median for the students, I'm going to write times here, for the students' times, these are about times again, are lower than the faculty's times. Again, just a quick way to get the context back in. So again, sometimes students like to put the specific number, and that's perfectly great. If you'd like to add the value, since it's real easy to do, you can do that, and it works great here. For spread, I'll do one with the numbers here. So I have really only 2 choices. I'm going to use range and IQR. So remember, range is just the gap between the max and the min, and the IQR is the gap between the quartiles. So let's do the IQR here. So IQR is just Q3 minus Q1. So for the faculty, it is 7. 15.75 minus 8.75 is 7 minutes. And likewise, the students happen to be the same. The IQR is 7. So that's going to be a nice comparison, easy one to make. They're both 7 minutes. You can my box plots aren't perfect to scale, but you can see in the box plot that they're about the same, and they should. They're 7 minutes in both cases. Now the range is definitely not the same here. So the range is much greater for the faculty. The range for faculty is 20.5 minutes, and the range for the students is 16.5. That's 12.75. So again, just subtracting maximum minus minimum, and this is just kind of my scrap work up here. Down here, I'm going to write it down and just write these two values down here. So I'm just going to do it as facts this time. So the student Obstacle times have the same same IQR, 7 minutes, as faculty, but have a lower range. 12.75 minutes versus 20.5 minutes. And one thing that I really can't stress enough is you don't assign value to it. Like sometimes people say it's better or worse. Avoid that kind of language. You're much better off just being factual about it. So don't give it your own judgment as far as what's better or worse, unless that's part of the task. If you have to make a defense, that's okay. But if you're just comparing, just keep it to the facts. Just say this is the range. You don't have to say that it's better or worse, because frankly it doesn't matter. It's really just about comparing. So just stick to the facts on that. And then the last thing we need to double check is outliers. So one thing that this particular task doesn't even allow you to do, you can't write about standard deviation here. You don't have that value, and you can't guess it from what you know. So same thing with outliers. It's typical that you don't get to choose which method you use. It's very often like the one here where you only have the choice, it's not really a choice, to use the 1.5 IQR method. So just to check the cutoff points here. So if I'm going to do I'll do the students on this side. So outliers, remember the lower bound is equal to Q1 minus 1.5 IQR. Now, here's the thing. It never says to calculate outliers. So if you are a person who can look at this graph and you can tell there can't be any outliers, you don't need to calculate this. So maybe I'll leave that for an exercise since this video is running a little bit longer than I wanted anyway. And the upper bound is Q3, 1.5 IQRs. But I can tell right from the picture that there can't be outliers. And the reason I know that is because this 1.5 IQRs, that literally is going to take the width of the box and make it 1.5 times bigger. So if you can visualize this box becoming longer, about 50% longer, then you've got your addition and subtraction piece. So you're going to subtract it off of Q1, you're going to add it on to Q3. When you subtract that number off, your cutoff point's going to be way down here somewhere. There's no way there's any outliers. Same thing on the upper bound. If you take Q3 and you add a box plus another 50% of a box, the cutoff point's way up here. So I'm going to actually check the faculty with you here. So the faculty is possibly not. This one might be. So we're going to check this one. I'm positive it's not on this bound, but I will double check the calculation just to show it again. So the lower bound is going to be Q1, which is 8.75. Take away 7. So that is 1.75. There are no data points below 1.75. So that one's checked. And we could see that visually too. There was no way this was going to be an outlier. It's just too close to Q1. But the upper bound, we have a Q3 was 15.75. And we have, oh, sorry, I forgot a step here. I forgot to multiply. I didn't need to in this case. I did make a small mistake here though. 1.7 or 7 times 1.5 is 10.5. Sorry. So it's even more extreme. 8.75 minus 10.5 is negative 1.75. 1.25. And likewise for the upper bound, I forgot to multiply. So I have to take that 7 times 1.5, or 1.5 times 7, however I'm going to look at it. So that's 10.5, and 15.75 plus 10.5 is 26.25. So this one is the cutoff point for outliers. So it looks like it's close, but it's not an outlier. So neither distribution has an outlier. And that's all we got to do for that. And like I mentioned, you don't have to calculate it. If you could have seen this right from the displays, then you could have just said that right away. But I thought it'd be smart just to look at an outlier calculation anyway. So anyway, this is part 1. I'm going to do another video for part 2 here. So thanks for listening, and hopefully this was helpful information for you.